Hello everybody. In this video we're going to do U-substitution integrals for Calculus 1 and AP Calculus. This is example 1. Our integral is x plus 1 raised to the 6th power dx. In this integral we're going to call x plus 1 u. So let your u become x plus 1. Then du will be the derivative of this. Derivative of x is 1, derivative of 1 is 0. And because we do it with respect to x, we attach the x. And here dx is equal to du. Now we're going to write everything in terms of u. Instead of x plus 1, we're going to write u raised to the 6th power. And instead of the x, we're going to write du because dx is equal to du. Now we know how to take the antiderivative of u to the 6th. We add 1 to the power and we divide by the same power number, which is 6 plus 1, 7. Now if we clean up a little bit more and bring u back, u was x plus 1 raised to the power 7 and divided by 7. Don't forget to attach plus c because this is indefinite integral. And if you would like to pull this 7 to the front, it is fine, which is 1 over 7 x plus 1 raised to the 7th power. Either form is correct answer. Example 2. Integral of x plus 1 times square root of 2x plus x squared dx. First we are going to rewrite this integral as integral of x plus 1 times 2x plus x squared raised to the 1/2. So we're going to convert square root to the power. Now we're going to call this part u. So let u become 2x plus x squared. Then du will be derivative of this. Derivative of 2x is 2 and derivative of x squared is 2x. And we attach the x because we take derivative with respect to x. Now we're going to solve for dx here. If you divide both sides on 2 plus 2x, dx will be du over 2 plus 2x. Now let's write everything in terms of u. So we have here x plus 1. Instead of 2x plus x squared, we're going to write u raised to the 1/2 power. Instead of the x, we're going to write du over 2 plus 2x. Now we're going to rearrange here. If you pull 2 to the front, factor out, what you have is 1 plus x, which is x plus 1 or 1 plus x. They cancel out. So now we are left with integral of u to the 1/2 du, and this 2 on the denominator we can pull to the front as 1/2. Now we know how to take the antiderivative of u to the 1/2. We have 1/2 in front, u to the 1/2. We add 1, express 1 as 2 over 2, and divide by 1/2 plus 2 over 2, which is 3 over 2. We have 1/2 here. Dividing anything by 3 over 2 means multiplying by 2 over 3. And we have u to the 3 over 2. These two cancel out, so we have 1/3. Let's bring u back. our u was 2x plus x squared and 3 over 2 plus c. Example 3. Our integral is x squared times quantity of x cubed minus 7 raised to the third power. This time we're going to call x cubed minus 7 part u because it is wrapped in parentheses and raised to the power. So let u become x to the third minus 7. Then du will be the derivative of this, which is 3x squared dx. Derivative of constant is 0. If you solve for dx here, dx will be du over 3x squared. Now let's rewrite everything in terms of u. We have x squared here. Instead of x to the third minus 7, we're going to use u raised to the third power. And instead of dx, we're going to use du over 3x squared. Here x squared cancels x squared, and we can pull 3 to the front of the integral sign. Because this is in the denominator, it's going to be in the denominator here. We have u to the third power du. Now we know how to take the antiderivative of u to the third. We add 1 to the power and divide by the same number. So we have 1 over 3 times 4, which is 1 over 12, u to the fourth power. And if you bring u back, it's going to be x to the third minus 7 raised to the fourth power plus c. Example 4. Integral of 1 over 3x minus 4 dx. Before we start u-substitution, we're going to rearrange this integral. We're going to bring 3x minus 4 to the numerator. So it will be 1 times 3x minus 4 raised to the negative 1 power. Because if you wrap 3x minus 4, we have here hidden secret 1, understood 1. So 3x minus 4 to the negative 1 power if you bring it to the numerator. Now we're going to call 3x minus 4 u. This is our u, 3x minus 4. Then the derivative of 3x minus 4 is 3 dx. Derivative of 3x is 3, derivative of constant is 0. If you solve for dx here, by dividing both sides on 3, du over 3 will be dx. Now let's rewrite everything in terms of u. This is our u to the negative 1 power, dx. And instead of dx, we're going to write du over 3. And you can pull this 3 to the front of the integral sign as 1/3. Now this is 1 over u. Integral of 1 over u du. Antiderivative of 1 over u is ln of u. You need to use absolute value sign because ln has to be positive. Plus c. You need to bring u back, so 1/3 ln of 3x minus 4 plus c. Example 5. Our integral is 3x times square root of x squared minus 5 dx. We are going to rearrange this integral as 3x times x squared minus 5 raised to the 1/2 power dx. We are going to convert square root to the 1/2 power. Now we're going to call this part u. So let u become x squared minus 5. Then the u will be derivative of this. Derivative of x squared is 2x, and derivative of 5 is 0. So derivative of this is 2x dx. And if you solve for dx, it's going to be du over 2x if you divide both sides on 2x. Now let's rewrite everything in terms of u. We have 3x here. Instead of x squared minus 5, we're going to write u raised to the 1/2 power. And instead of the x, we're going to write du over 2x. Here, x is cancelled out, and we can pull 3 over 2 in front of the integral sign. Now we have u raised to the 1/2 power du. Now we know how to take the antiderivative of u to the 1/2. We add 1, express 1 as 2 over 2, and this is 3 over 2, so divide by 3 over 2. Anything divided by 3 over 2 is multiplied by 2 over 3. So we have 3 over 2 here, multiplied by 2 over 3. We flip this fraction, and u to the 3 over 2 plus c. Here 3 and 2 cancels out cross, so we have u to the 3 over 2 plus c. And if you bring u back, which is x squared minus 5 raised to the 3 over 2 plus c, is our final answer. Example 6. Integral of ln of x squared over x dx. This time we're going to let ln of x be our u. So ln of x is our u. Let u become ln of x. Du will be derivative of this. Derivative of ln of x is 1 over x dx. And if you solve for dx here, by multiplying both sides by x, you obtain x du. Now let's rewrite everything in terms of u. We have u to the 2nd power over x, and instead of dx, we're going to write x du. Here x is cancelled out because 1 is on the numerator, 1 is on the denominator. Now we have u to the 2nd power du. Now we know how to take the antiderivative of this. We add 1 to the power and divide by the same. And if you bring u back, which is ln of x raised to the 3rd power divided by 3 plus c. If you would like to pull 3 in front, 1/3 ln of x raised to the 3rd power plus c. Either form is correct. Example 7. Integral of negative x times 2 to the x squared minus 2 dx. Here we're going to call x squared minus 2 our u. If u is x squared minus 2, then du will be derivative of this, which is 2x dx. And then if you solve for dx, dx will be du over 2x. Now let's rewrite everything in terms of u. You can pull this negative sign in front of integral sign, and then you have x times 2 to the, instead of x squared minus 2, you write u, and instead of the x, we have du over 2x. X is cancelled out. So here we have negative integral of 2 over u over 2 du. Using the exponential rule, we have the same base. You can merge these two numbers. So negative integral of 2 to the, here we have hidden power 1, 2 minus 1. So whenever we have division on the same base, we subtract the powers. power of numerator minus power of denominator. Now we can bring u back and we can use this integral. Integral of some constant number a to the u du is equal to a to the u over ln of a plus c. Here in our case our a is 2. So negative 2 to the, instead of u, we're going to use x squared minus 2. And we have minus 1 here, all over ln of a, in our case ln of 2 plus c. You don't need to derive this integral or prove it, just use it from here as a template. You can derive it in Calculus 2 or you can check the proof of it if you wonder. Here, this is one possible answer. Our another possible answer from here, you can pull 2 in front of the integral sign. So it will be negative 1/2 integral of 2 over u du. And here we know that a to the u over ln of a plus c. So negative 1/2, 2 to the x squared minus 2 all over ln of 2 plus c. And if you would like to rewrite better, negative 2 to the x squared minus 2 all over 2 times ln of 2 plus c. So in the second form we didn't merge 2's, in the first form we merged 2's. It's totally up to you. Pull negative 1/2 to the front, don't merge 2's, or just merge 2's here and then write like this. It's just exponential rule. Example 8. 16x times 5 raised to the 4x squared plus 5 dx. Here we are going to call the power of 5 u. If u is 4x squared plus 5, then du will be derivative of this, which is 8x dx. And if you solve for dx, dx will be du over 8x. Now let's rewrite everything in terms of u. 16x times 5 to u, because 4x squared plus 5 is our u. And instead of the x, we have du over 8x. 16x divided by 8x is just 2, and you can pull in front of integral sign. Now we have 5 to the u du. We know that a to the u du is a to the u over ln of a plus c. In our case, our a is 5. So we have 2 times 5 over u, we're going to bring it back soon, over ln of a. Instead of a, we're going to write 5 plus c. And our u is 4x squared plus 5. So this is our answer. 2 times 5 to the 4x squared plus 5 over ln of 5 plus c, using this template integral. Example 9. Integral of 12x to the third times e to the x to the fourth plus 1 dx. Here we're going to call x to the fourth plus 1 our u. X to the 4 plus 1 is u, then du will be derivative of this, which is 4x to the third dx. If you solve for dx here, dx will be du over 4x to the third. Let's rewrite everything in terms of u. We can pull this 12 in front of integral sign. We have x to the third, e to the, instead of x to the fourth plus 1, e to the u, and instead of the x, we have du over 4x to the third. X to the third cancels x to the third. You can pull this 4 in front of integral sign, and 12 divided by 4 is 3. If you clean up, you have 3 integral of e to the u du. Everybody loves e function because integral of e to the u is e to the u plus c. Now, if you take the antiderivative, it will be 3e to the u plus c, and if you bring u back, it's gonna be 3 times e to the x to the 4 plus 1 plus c. Example 10. We have integral of 45x to the 4 over 3x to the 5 minus 1. If you observe the integrand, 3x to the 5 minus 5 will be our u, because derivative of x to the 5 can cancel out x to the 4. So let u become 3x to the 5 minus 1. Then derivative of this will be 15x to the 4 dx. And if you solve for dx here, it's gonna be du over 15x to the 4. Now let's rewrite everything in terms of u. We have 45x to the 4 on the numerator. In the denominator, we're gonna write u, and instead of the x, we're gonna write du over 15x to the 4. X to the 4 cancels x to the 4. 45 divided by 15 is 3. Now we have 1 over u du. We know that integral of 1 over u du is ln of u, or integral of 1 over x dx is ln of x plus c. Don't forget to use absolute value of x, because ln function cannot go to the negative as the domain. So here, if you take the antiderivative of 1 over u, it's going to be ln of absolute value of u plus c. And if you bring u back, it's gonna be 3x to the 5 minus 1 in the absolute value plus c. This was the last example of part 1. See you in part 2.